Good afternoon to everybody. My name is Giovanni Mazzeo. I am a researcher of the CINI group, which is a consortium of Italian universities. In the context of InfraStress, CINI is the technical coordinator, and besides of this, we are responsible for several components that have been used in the current InfraStress architecture, such as detectors and also security and information event management systems. One of the components we are most proud of is the component that we are that I am presenting today. This is a tool that allows to simulate an industrial process and conduct attacks on the simulated industrial process to understand the impact of attacks and also the possible cascading effects that could occur in the infrastructure. So let me present our solution at a glance. Our solution is an extension of a typical cyber range product. What is a cyber range? A cyber range is maybe most of you already know about a cyber range. It is a virtual environment that is usually used for cybersecurity training. What we have added on this cyber range solution, we have provided additional features on the cyber range, and we have extended a typical cyber range architecture with the possibility of simulating sensitive industrial processes, virtualize common SCADA control systems, and also virtualize devices and IoT elements that can be used in the simulation of a typical industrial Internet of Things deployment. So it is composed by four main layers. We have a graphical user interface that allows to configure the solution. And then we have three layers. One for the simulation of information technologies. Another layer, yeah. Everything all right?
Yes, yes,
okay.
Yes.
Okay. So other two layers that are the industrial specific ones. So one layer for the simulation of operational technologies, that is those technologies that have a direct direct interaction with the physical process. And then we have a very important layer that is the layer for the simulation of the physical process. The architecture is as follows. We have, can you see the mouse, the pointer? Well, it doesn't matter. So we have, okay.
We can see it.
Okay, perfect. We have a unit that reads from a storage of archived models of the process that executes the model and generate the data feed that are representative from the real industrial process. This unit interact with an industrial, very standardized communication protocol that is the OPC standard, the OPC protocol, and it provides the data feeds of the simulated process to the other units, which are also simulated. So, for example, the RTU, the HMI, the MTU, typical units of a SCADA system. And then besides that, we have other units which are simulated that are typical of a cyber range, that already exist in a cyber range, that are units, for example, for the simulation of the application server, of the database server, web server, and so on. And finally, we have implemented a solution for the configuration of the network in the industrial infrastructure. The important part that I want to highlight is, as I already said, is the simulation of the physical process. So it is very important because here we have to produce accurate, we have to reproduce the industrial process and provide and produce accurate data. We have our approach is to run predefined dynamic models that must be built before, obviously, by the security engineer. And then our solution interact, as I was saying before, interact with the other components using the OPC standard. This is very important because this means that every simulator can be used with our solution. So you can change the simulator, for example, OpenModelica, Simulink, and then just expose the data feeds over an OPC interface, and everything will be the same for the rest of the virtual testbed. So in this way, we have a higher flexibility on our solution. Today, I'm going to show you an attack that we are going to conduct that we conducted on our simulator with regards to a specific pilot of our process of our project. So the pilot that we are considering is the Carmagnani pilot. That is a chemical storage case study. Carmagnani highlighted a critical industrial process in their infrastructure. This is an industrial process, a critical process where there is the loading and unloading of chemicals that are highly flammable. So they are very risky in terms of safety for human being and for the environment. What you will see in the demonstration, I will show you. I will reproduce a video. What you will see the configuration of the simulator. In this case, we are using a YAML configuration file just for simplicity, but it is also configurable via a graphical user interface. And then we will have such an architecture. So we will have this architecture where we have the model that simulates the industrial process that we discussed here. Then we will have some units, for example, RTUs for collecting data from the industrial from the simulated process. Then we have MTUs, and then we will have an attacker machine that will conduct the attack. So you will see here the simulated physical process. So this is the physical process that has been implemented in OpenModelica and that we use in our simulator to simulate the process and produce the data feeds. You will see a certain trend of the loading and unloading procedure. Let me clarify that this is just a graph that is not really representative of the reality. Why? Because we had to conduct the experiment in a very short time. But obviously, this should be this flow should occur in a time window that is like 24 hours of execution. So this is why it won't be in that 24 hours. So you will see the HMI from the demonstration. You will see how we will get access to the HMI and from where we can monitor the situation of the different units, for example, the tank, the status of valves, and so on. And then what you will see the execution of the attack. So the steps of the attack will be the following. We will gain access to the gateway machine. We will escalate privileges in the gateway machine that is used to that can allows us to get access to the internal network and so monitor the status of the infrastructure. Then we will gather information on the master terminal units and from the HMI. Finally, we will sniff the network in order to understand how to inject malicious packet to the RTU. So the objective will be to modify the measurements and the values that are shown to the HMI. So let me show the video. 1 second, please. Can you see, right?
Yes.
Okay. So we will deploy the scenario that I was telling you before. And once we will have the scenario, so we will configure what we are doing here. We are configuring, for example, the model. We are saying, okay, what modeler I want to use? The Open Modelica one. So I will. This will load this particular model in the simulator. We have also other models of our project, for example, pilot. But in this case, we select the tank model, that is the model of the Carmagnani pilot, and then we specify what actuators and sensors we want to expose on the OPC interface. Finally, we configure all the other units. It's not really important right now on the specific of this configuration because it could be too much detail. So we are providing some security-related parameters that says that set the level of security of the infrastructure in order to conduct our testing. Then we deploy the scenario. Don't worry about those failures; those are normal. So we have all the virtual machines that have been executed, that are running. We can now go and get access, for example, to the attacker machine from which we can conduct the attack. Our idea is to target the valves actuators. So what we want to do as a first step, we want to get access to the remote machine, to the gateway machine. How we do this? We can brute force, for example, we can conduct a brute force attack against the gateway machine to steal, for example, with some tools, we could steal the credentials of the gateway machine. Once we have this, we can connect to the internal. We can connect to the internal HMI. So we inspect the network and then we go in our HMI. So the attacker now is able to get access to the HMI. He is able to reach the HMI of the infrastructure. He can steal the passwords from the browser's data, for example, since he is now he has exploited the machine where the HMI is running. He steals the credentials, and once he has been able to steal the credential, he can monitor the status of the infrastructure and gather information on the infrastructure. So what does it mean? That he can understand, for example, which sensors are doing what, are necessary for what, which actuators are used for. So it is an important step of the attack because the attacker has to learn about the infrastructure status and in this way understand how to proceed in the attack. So we have here the status of, he can, for example, monitor the status of tanks and everything. And now, so he can sniff the network. In order to do that, the important aspect is to escalate the privileges of the users. So the attacker can escalate the privileges of the user by, for example, leveraging a vulnerability on the operating system that most of the time are outdated and not updated with the security patches. Once he has the control of the machine and has root privileges, he can sniff the network and understand the packets that are sent to the the RTUs to the RTUs. Sorry. In this way, once he observed the Modbus TCP packet, he can understand how to modify the values of the parameters, and he can, so the valve 2, the actuator of the valve 2, so that opens or closes the valve, will be the target of the attack. So in this way, we want to inject the value, and now we change the tank of the valve. Sorry. So now you will see the values of the tank fluid that is going to increase because the valve is still opened, even though it must be closed. So in this case, we are causing an extraordinary overflow on the secondary tank of the critical process of our simulated infrastructure. So that's it from my side. I hope I have been clear. The time wasn't too much, so I know a lot of information, but I hope that the idea was clear on the possibility that our tool can give to the security engineer.